Please note that filming text on a whiteboard requires extremely bright studio lighting. Subsequently, sunglasses were worn during the filming of this video to prevent damage to my retinas. A note on how to use these sessions. Jot down the notes as we go, so we'll help you learn the material in a more interactive way and you can use them as study notes later. Also, in the small chance that a discrepancy arises between the professor's notes and mine, always go with your professor. They're the one grading you. Lastly, any examples or analogies used in the session are not meant to support or criticize politics, religion, or lifestyle. They're merely learning tools to help understand the material. Alright, guys and girls. It's time to get cracking.
Alright you guys, so today we're going to be talking about carbonyl compounds. In particular, we're going to be talking about a type of carbonyl compound called aldehydes and also ketones. Okay, these represent a specific type of carbonyl compound. And hey, whenever we introduce a new topic, we always start out by talking about general features. So let's go ahead and write that up on the board. Okay, so let's start out by talking about what aldehydes and ketones even look like. Okay, so let's start out with aldehydes first. And an aldehyde looks like this. It's a carbonyl compound with at least one hydrogen directly attached to it. So at least one hydrogen directly attached to that carbonyl. On this other side, this could also be a hydrogen if you want, or it can be an alkyl group, an R group, okay, any carbon group, okay? But hey, as long as you have one hydrogen attached directly to that carbonyl, you're qualified to be an aldehyde, okay? Okay, so now what does a ketone look like? Well, a ketone looks very, very similar to an aldehyde. It's still going to be a carbonyl compound, but this is going to be a carbonyl directly attached to two R groups, okay? So an R group on this side and an R group on this side. R groups are just alkyl groups, carbon groups, okay? So let me go ahead and just leave these up here as just CH3 on this one and a CH3 on this one, for example. Okay, so the first thing I want to point out about these aldehydes and ketones is just like any other carbonyl compound, okay? Any carbonyl compound is going to have a carbon double bonded to an electronegative oxygen. Carbon double bonded to an electronegative oxygen. Oxygen is more electronegative than carbon. And if oxygen is more electronegative than carbon, that means that this oxygen is pulling electrons away from that carbon. Okay, so oxygen is pulling electrons away from this carbon. If it's pulling negatively charged electrons towards the oxygen, then oxygen is going to become more negative. So we say that this oxygen is partially negative. And if this carbon is getting its electrons taken away from it, pulled away from it, then we say that this carbon is going to become more positive, partially positive. Because it's having negatively charged electrons pulled away from it. Okay, so since this carbon is having negatively charged electrons pulled away from it, it's partially positive. It's electron deficient. Oxygen's pulling electrons away from carbon. Carbon's like, whoa, I don't have enough electrons. I don't have enough electrons. I'm electron deficient. I'm partially positive. So hey, you guys, something that's electron deficient, something that's electron poor, these are known as electrophiles, right, you guys? So hey, let's go ahead and identify this carbon that's directly connected to that oxygen. This is an electrophile, abbreviated E+. And since these carbons that are directly connected to those oxygens, since they're electron poor, since they're electrophiles, they're looking for someone to come and share electrons with them, right? These carbons are like, hey, somebody give us electrons. And who is that somebody, you guys? Who's going to come in and share electrons with those electrophiles? Nucleophiles, right? So you'll see that a very common reaction with carbonyls in general is nucleophiles coming in and sharing electrons with those carbons, okay? They'll make bonds with those carbons. Okay, so that's the first thing I wanted you guys to see, that these carbons of the carbonyls are electrophiles. The second thing I want to point out here, you guys, is about the hydrogens that are on the carbon groups connected to the carbonyl. Okay, so hey, do me a favor and go ahead and draw in one of these hydrogens that's on this carbon. Okay, so we've got a carbonyl. One carbon away from that carbonyl is known as the alpha carbon. Alpha is one away. Okay, so here's your carbonyl. This carbon that's one away from that carbonyl is the alpha carbon. And hey, you guys, if this is called the alpha carbon, what do you think the H's on the alpha carbon are going to be called? Alpha hydrogens, okay? And there's something special about these alpha hydrogens that are on the carbon one carbon away from a carbonyl. So do me a favor and go ahead and put a little box around this alpha hydrogen and make a little note for me here. And let's say that these alpha hydrogens, these equal slightly acidic. Slightly acidic, meaning that these hydrogens can be pulled off by a base. They can be deprotonated, okay? Okay, so we said that you have a carbonyl. One carbon away from the carbonyl is called the alpha carbon. Hydrogens on the alpha carbon are known as alpha hydrogens. And we said that these alpha hydrogens are slightly acidic. They can be deprotonated, okay? What does this mean? Well, check this out, you guys. Let's go ahead and just take a carbonyl, for example, and let me go ahead and draw in its alpha hydrogen, okay? If you take a base, you can deprotonate, you can pick up that hydrogen with the base and kick these electrons onto that carbon. Okay, let's see what the result of this will be. You'll have your carbonyl, and these electrons just got kicked onto this carbon. So let's put a lone pair of electrons on that carbon along with a negative charge. And when you look at this thing, you guys, this carbon with this negative charge on this, does this look at all funny to you? This should look really, really strange because, hey, a carbon with a negative charge on it is really, really unstable. This is really hard to form, a carbon with a negative charge on it. So, hey, how is this possible? Why are we saying that this alpha hydrogen is slightly acidic? It can kick its electrons onto that carbon and put a negative charge onto it. Well, check this out. We say that an alpha hydrogen is slightly acidic because of resonance. Because of resonance. Because this guy has resonance structures, and the more resonance structures you have, the more stable you are. Okay, so hey, let's take a look at this resonance structure for this guy. Okay, so hey, you can take these electrons, use them to form a double bond between this carbon and this carbon, and hey, you can then kick these electrons up to that oxygen. And this will give you this as a resonance structure, so make sure to draw your double-headed resonance arrows. Okay, so you just formed a double bond between this carbon and this carbon by using these electrons to form a double bond between those two, so let me draw that out. And hey, you also kicked electrons that were in this carbon-oxygen double bond up to that oxygen. So, sorry, I should have drawn those two lone pairs on that oxygen to begin with. Okay, so this double bond broke and kicked the electrons up to this oxygen, now putting a negative charge on that oxygen. Oh, and don't forget to draw your resonance brackets around these resonance structures. Okay, so we've got a carbonyl. One carbon away from a carbonyl is known as the alpha carbon. Hydrogens on the alpha carbon are known as alpha hydrogens. And we said that these guys are special. Why? Because they are slightly acidic. They can be pulled off by a base to put a lone pair, a negative charge on that carbon, which is normally never stable enough to form, but it is stable enough to form in this case because of resonance, because of the resonance structures that it can form. But hey, you guys, this means nothing to you right now, okay? So if you're looking at this and it's like, oh my gosh, what is he talking about? Don't worry, we're going to get into this big time later when we talk about the reactions that aldehydes and ketones undergo. For now, I just want you to realize that these alpha hydrogens are acidic. They can be pulled off, okay? So we'll get back to this big time later. Okay, so that's basically all the general features I wanted you to know about aldehydes and ketones. Let's go ahead and move on to how these aldehydes and ketones react, the reactions of aldehydes and ketones, okay?